Welcome to day 2 of solving systems using elimination. As a warm-up, solve the system using elimination. Let's see how you did. Again, step 1 is to check to see that the equations are in standard form. They are. Step 2, look at the variables and see which one has the same coefficient. In this case, the x's had the same coefficient. One was positive, one was negative, so we're going to add the equations together. We get negative 7y equals 14. Divide both sides by negative 7 to get y equals a negative 2. Now that we know y, we go back and substitute it for the negative 2 for y. You have 3x minus 4 times negative 2 equals 5. 3x plus 8 equals 5. We have... subtract 8 from both sides to get 3x equals a negative 3. And divide both sides by 3 to get x equals a negative 1. Put it in as a coordinate to get negative 1, negative 2. Again, let's review the steps for the elimination method. Step 1, put the equations in standard form. That means ax plus by equals c. Step 2, figure out which variable you're going to eliminate. You want to look for variables that have the same coefficient. Step 3, add or subtract the equations. You're solving for the variable. Step 4, plug back into one of the equations to find your other variable. Just like we did for substitution, you're substituting the value into the equation. And step 5, check your solution. Substitute your ordered pair into both equations. Again, those are the steps we're going to take when we solve using the elimination method. So, in this case, we have y equals 7 minus 2x and 4x plus y equals 5. Looking at step 1, we don't have the first equation in standard form. I need to add 2x to both sides to get 2x plus y equals 7. Now my equations are in standard form. When I look at my equations, I have y's that have the same coefficient. They're both positive, so we're going to subtract to eliminate y. So we're going to have 2x minus 4x, which is negative 2x, and 7 minus 5, which is 2. Divide both sides by negative 2, you get x equals a negative 1. Solving to get y, we have y equals 7 minus 2x. Substitute the negative 1 in for x. 7 minus a negative 2 is 7 plus 2, which is 9. And then we check our solution, negative 1, 9 for both systems. And it checks. Let's take a look at another example. Again, step 1, are they in standard form? The answer to that is yes. Now we look to see if either of them have the same coefficient. In this case, neither equation has the same coefficient. So sometimes, as in this example, you're going to have to get the coefficients to be the same. I chose to get y's the same. So I'm going to multiply my entire top equation by 2, my entire bottom equation by 3. So my top equation becomes 8x plus 6y equals negative 38. My bottom equation becomes 9x minus 6y equals negative 30. Adding them together, 17x equals negative 68, the y's cancel out. Divide both sides by 17, x equals negative 4. Now that I know what x is, I substitute the negative 4 in for x in either equation. I chose the first one. So I have 3 times I chose the second one. 3 times the negative 4 minus 2y equals negative 10. I have negative 12 plus 2y equals negative 10. Add 12 to both sides. I end up getting negative 2y equals 2. Divide both sides by negative 2. Y equals negative 1. So my solution is negative 4, negative 1. Take a look at another example. See if you could do this one on your own. Again, looking at the equations, they're already in standard form, but I don't have any of the equations that have an x or a y with the same coefficient. I have to make them have the same coefficient. To do this, I'm going to multiply the top equation by 7, the bottom equation by 3. I have 21x plus 49y equals 147 up top, negative 21x plus 6y equals negative 42 on the bottom. I'm going to add these two equations together so that the x's cancel out. Giving me 55y equals 105. Divide both sides by 55. I get y is approximately 1.91. Substituting in the 1.91 for y, I end up with 3x plus 13.37 equals 21. Subtract 13.37 from both sides, I get 3x equals 7.63. Divide both sides by 3 to get x is approximately 2.54. Your homework assignment is on page 378, numbers 15 to 20.